a jumper is it's basically there's these pins on like the older ISA cards like I was talking about. And then a jumper is this piece of metal that's got some grooves cut into it, some holes cut into it, and you slide this jumper down over a couple of these pins. And basically when you slide that down, since it's made of metal, it forms this connection and it creates this circuit. And when you create this circuit between these two pins, you're altering the behavior of that card or that device or that motherboard circuit or whatever. Okay? And you know, the only way you'd know to hook stuff up is you have to look at some manual. Look at the manual for the card or the motherboard to see what the action's going to be when you put a jumper over like these two pins or those two pins or those two pins and so on. And then you can, you know, if you want to alter the behavior in some way, you can hook up that jumper. Now, like I said, that's probably a little outdated. Any new PCI card doesn't have these. Even newer ISA cards, I haven't really seen them on those, just on older ISA cards. And nowadays and in the future, you're typically going to alter the behavior of some device through drivers. So you're gonna load and configure the drivers, and in that configuration process is how you're going to alter the behavior of the device, just like you would have in the old days with jumpers. Okay. Now these drivers, they can be in the kernel directly, and they can be compiled into the kernel. And if you're going to add a driver directly to the kernel, you're going to have to recompile the kernel to do that. And that's that's no place for a novice user. Even an intermediate user should be really careful when you're recompiling the kernel to do something. Okay. So another option that Linux has, instead of having drivers located directly in the kernel, is it has what's called kernel modules. Now these modules are like drivers that are loaded on demand. So when some device gets accessed, if the drivers for that device are not in the actual kernel itself, and they're in some module, then when that device gets accessed, that module will be loaded then, and then you'll be able to access that device. Okay? Now the kernel modules are controlled by some files. One of those files is the modules.conf file. On some systems it's called conf.modules. Okay, now this file basically it has a format in it that says for the various devices on your system, you know, what drivers do they need to operate. Okay, so that's the information that's in modules.conf, is for each device, you know, what drivers need to be loaded for that to work. Okay, and so that's what's going to happen. They're going to be loaded on demand. Now there's some commands that operate on modules. insmod for install module or insert module. Mod probe, which does an insert, but it does a much more sophisticated sort of insert. We'll talk about that in a second. And lsmod to list information about modules already installed on your system. Okay, so for the insmod command, there's some various options you can use to install modules on your system. There's the -F option, and what this does is force installation. So a lot of times these modules you're installing, these drivers, are like binary executable files in some sense, and they've been compiled for some kernel and some architecture. And maybe the kernel version they were compiled on is different than the one you're running. But you should be able to do it. If it's not too far off, you should be able to do it with the -F option and just force the installation, and then that module will then be loaded, and it will be in the list of modules that are active on your system. Okay, and then there's the -K option. Now the -K option sets an auto clean flag. So what that says is once the module is inserted, it'll be working and everything will be fine. But once it's inactive for some period of time, then the -K option says to remove that module from the system. And the reason Linux deals with kernel modules as opposed to having every single driver inside the kernel itself is it just saves memory. That way the kernel's not all big and unwieldy and takes up a lot of memory on your system. It's nice and small and streamlined, and then when some device gets accessed, we load that module in, we do our work, and then when that device is done being accessed, we take the module out. Again, just to make everything more streamlined. And this -K option says that after the module has fallen out of use, once that device is not being accessed, you can take the module out of the system. Okay? Another useful command or an option for the insmod command is -P. I love these options because it just like does a test run. It doesn't actually load the module, just does a test to let you know what would happen. And I like commands like that, especially when you're dealing with stuff having to do with the kernel. You don't want to screw anything up there. Okay, so there's the insmod command. Now, the drawback with insmod is that it just inserts one module. Just like when we were installing software way back when, we talked about, you know, dependencies in software. okay? And when you went to install some piece of software, it depended on some library. You had to install that library. Maybe it installed on some, it depended on some other program, and you had to install that program, which depended on other libraries, and it just became this whole tedious process. Well, that's what mod probe is for. Mod probe is basically deals with all those dependencies. Now, there's another file up there called modules.dep, which stands for modules.dependency. Okay, and basically this file has a lot of information about what modules depend on other modules. So when you go to insert a module with mod probe, it's going to look at the dependency file and determine what other modules must be loaded for this one to work correctly. Okay, so same kind of thing as insmod. The -k option inserts it with the auto clean option on. Basically, it's the same kind of thing here. And like I said, it just looks at the module dependency information when it does the loading. So it might actually load many more than just one module if that's what it takes to get the things working. Okay, and then there's lsmod, and basically it's just if you want to know what modules are loaded at at any moment in the system, you can determine that with the lsmod command. Okay, and it'll tell you the module and the size and what its use is and that kind of stuff. Okay, so that's information about kernel modules, and then going back here, let's talk a little bit about making the device accessible to the users. Actually, before we talk about how to make hardware accessible to the users of your system, I just want to talk more about modules, and I want to do it on the Linux screen so I can show you some stuff firsthand that we've been talking about on the whiteboard. The first thing I want to do is show you the modules.conf file. And you can see I'm in the /etc directory, so that's where modules.conf is. So modules.conf's there. The format's pretty easy to understand. If you did a man page on modules.conf, you would see actually there's a lot more directives and options for how to set up modules.conf, and it could be quite complicated. But typically it's pretty easy, and this one's no exception. So here the format is, for most of these lines, is that it says alias, and then it has two fields after the alias. Now what this is saying, take this one for instance, this one is saying the first field is the hardware, and the hardware it's talking about is Ethernet 0, or the Ethernet card. And then the next field is the device, or the driver, or the module that needs to be loaded for that hardware device. Alright, so this is saying the PCNet32 module must be loaded so I can access my Ethernet card. And the SCSI host adapter, in order to access that, I need to have the bus logic module loaded. Alright, now this one down here is a little bit special, the SB module is being loaded. And what makes this special is that it also has an options line associated with it. So when the SB module is being loaded, then all of these options or arguments or parameters, whatever you want to call them, are being set. And they're being sent to the module so that when the module starts up, all these options are then being set to these values. Now, if you're going to set options with a module, you need to consult the modules documentation. There's no possible way that I could generalize about all the different modules and the settings that you want to use. And also, just the names of the parameters change. Even if they're setting the same thing from one module to another, sometimes the name of the parameter changes. So you need to consult the modules documentation in order to set options for a module. Now let me do the lsmod command, and this lists all the modules on my system. And you can see the various modules here. There's the PCNet32 module, there's the bus logic module, here's a module for a CD-ROM player. And you can see this module's got the auto clean feature set. And that's that feature that means that it will be unloaded off the system if it's inactive for some period of time. And the way Red Hat deals with that is it has a cron job. Remember when we were talking about cron jobs, that's the utility for regularly scheduling things at some regular interval. And Red Hat has this cron job that runs every 10 minutes, and if some module is unused in that 10-minute cycle, then it's loaded off the system. All right, and it's not removed or anything. It's just made inactive. And then when I go to access the CD again, if it was inactive and unloaded, then I go to access the CD again. Then it will be loaded back in for that time. All right, so that's the way modules work. They don't take up unnecessary amounts of memory for sort of like non-critical devices like a CD player. Now things like a PCNet, this is controlling my Ethernet card, and bus logic is controlling my SCSI host adapter. So those are more important, right? Controlling the Ethernet card and the SCSI disks and things like that, these are more important features. They do not have auto clean set. And the reason they don't have auto clean set is because the trade-off is weighted the other way now. It's better to just have that thing in memory all the time, so it takes up some memory, fine, but the access to those devices is now going to be faster. Every time I access my SCSI disk. I don't want to have to load some module out of memory. All right, so that's the basic rundown there of why things have auto clean and why some things don't. Now, another thing I want to do before we go back to the whiteboard is just to show you when you do an insert mod or a mod probe, when you do those commands, where do those modules come from? Where are they being inserted from? And I want to show you that now. So the first part of the directory path that they're being inserted from is /lib or /lib/mod.